Good day. Today we're going to discuss how to present your data in such a way that it will answer your research objectives. For this discussion, we're going to consider the research entitled The Relationship Between Self-Esteem and the Mathematics Performance of Grade 10 Students. This study will be used as our example. As we can see here in our conceptual framework, the independent variable is the self-esteem and the dependent variable is the mathematics performance. It is very important to understand the conceptual framework because out from the conceptual framework, we are going to construct the research objectives as well as we are going to identify the statistical tools to be used in our research. In this case, the research objectives are to describe the level of self-esteem of grade 10 students, to describe the level of mathematics performance of grade 10 students, to determine the significant relationship between the self-esteem and the mathematics performance of grade 10 students, and the last one, to determine what model best describes the relationship between the self-esteem and the mathematics performance. In this case, the first two objectives will be addressed by using descriptive statistics, which is mean. The third research objective will be addressed using person product moment correlation coefficient. And the fourth one will be addressed using simple linear regression. It is also important to understand the parameters because the parameters will help you how to interpret the mean of your study. In this case, we have two parameters. One parameter for the self-esteem and another parameter for the mathematics performance. Let us say that the researcher of this study already gathered the data. So the data is presented in the Excel format. As we can see here, we have the column for the self-esteem and another column for the mathematics performance. Now, in this case, there are 29 respondents in this study. So, now, how we are going to use Excel to calculate the statistical portion of our research. One feature of the Microsoft Excel is the use of Megastat. Now, in this case, I am going to show to you how to use the Megastat in Microsoft Excel. Now, since the first two research objectives will be addressed using descriptive statistics, we are going to do first the descriptive portion of our research. Now, you go to formula, data, data rather. So you go to data and then you can see here Megastat. Okay, so the Megastat is placed in the ribbon on the rightmost part of the ribbon. Now, click Megastat and this will be the prompt. Now, you are going to click the descriptive statistics and then we are going to input the range. The range would be the self-esteem and the mathematics performance. So self-esteem, click and drag up to the last data for our uh, mathematics performance. And then we are going to unclick this sample variance and minimum maximum range. And then, okay, okay. As we can see here, the Microsoft Excel created another tab in our file. Here, we have descriptive statistics. The self-esteem has 29 data with the mean of 19.76. The mathematics performance has a mean of 81.9 uh, 81.9. If we go back to our parameters, okay, if we go back to our parameters, we have for the self-esteem, the mean is 19.76. This 19.76 falls in this range, 18.01 to 24. The level of this self-esteem is high. Okay, so the respondent got a high self-esteem, high level of self-esteem. This high level of self-esteem indicates that the student has high level of self-esteem towards mathematics subject. Now, in the mathematics performance, the respondents obtained an average of 81.9. Okay, if we go back to our parameters, the 81.9 falls in the satisfactory level. This means that the students in this level has developed the fundamental knowledge, skills, and core understandings, and with little guidance from the teacher and or with some assistance from peers, can transfer these understandings through authentic performance task. Okay, now we already addressed the first two research objectives. The level of self-esteem of grade 10 students is high, and the mathematics performance of the respondents, which are grade 10 students, is satisfactory. Now, let us proceed to the third research objective. Let's go back to our data. Now, remember that the research objectives, the third research objectives is we have to determine the significant relationship between the self-esteem and the mathematics performance of grade 10 students. In this case, we're going to go again to Megastat, click Megastat, and then we're going to use the correlation regression. Okay, click correlation regression, and then we are going to click the correlation matrix. Now we have input the range. We're going to highlight the data in self-esteem and mathematics performance. Okay, and then click OK. Now, in this case, in the output tab, okay, right below the descriptive statistics, we have the correlation matrix. So this is the correlation matrix of our data, the self-esteem and the mathematics performance. Now, as we can see here, okay, in the 2 by 2 matrix, okay, the mathematics performance versus self-esteem has a coefficient of 0.933. Okay, now as we can observe, this cell has colored yellow. Okay, if the cell in the correlation matrix has a color similar to this one or the same with this one, okay, the yellow color, that means the coefficient is uh, okay. If the cell has a color, okay, yellow, this means that the coefficient is significant at alpha equals 0.01. If the color of the cell is similar to this one, something like flesh color, this means that the coefficient in the correlation matrix is significant at zero point zero 0.05 level of significance. Now, if the color of the cell is white, like this one, this one, this one, okay, that means we're going to accept the null hypothesis. Okay, the coefficient in the cell is not significant at zero point zero 0.05. So in this case, the person R of the mathematics performance and the self-esteem is 0.933. Okay, if you can still remember in your statistics and probability subjects last year, if the R value is uh, belongs to the range 0.81 to 0.99, that means the relationship between self-esteem and the mathematics performance is very high positive relationship. That means that if the self-esteem increases, the mathematics performance also increases. Okay. The ranges in the person moment correlation coefficient was then discussed to you in your statistics and probability subject in your grade 11. Okay. Now, since the self-esteem and the mathematics performance is they have significant relationship, then we can now proceed to the fourth research objective, which is to determine the model best describes the relationship between the mathematics performance and the self-esteem. To do that, okay, we go back to our sheet one. Okay, to do that, we are going to click Megastat, then correlation, regression, then regression. As we can see here, we have uh, here independent variable. In this case, our independent variable is the self-esteem. Okay, we have to click and highlight the data in self-esteem, and then we're going to click this one for our dependent variable, and then click and highlight the data for the mathematics performance. Then click OK. Just click OK. As we can see here, we have the regression analysis, okay, just below our correlation matrix. In the regression analysis, we can see here that the R squared is 0.871. Okay, if you can still remember in your statistics and probability subjects in grade 11, this R squared will tell us how many percent of the data is being explained by the model. In this case, we have 87.1% of the data is being explained by our model. Okay. The other 12.9% of the data is or affected by other factors. Okay. Now, let's go to our regression output. Okay. As we can see here, the p-value of the self-esteem is 1.67 e minus 13. Okay. This value is actually 1.67 times 10 raised to the power of negative 13. So that means we have 0.000000000000167. So very small. Okay. Take note that the level of significance that we are going to consider in our study is 0.05 only, or 5%. In this case, since the p-value is less than the significant uh, significance level, this means that our self-esteem is a predictor to the mathematics performance. Okay, the coefficient is 2.0873. In this case, we can now create a mathematical model that will explain the mathematics performance. So we can have y equals 2.0873 times our x, which is our independent variable, okay, plus the intercept, which is 4.8655. So this is now our model. So y equals 2.0873x plus 40.655, where y is the mathematics performance and x is the self-esteem. So if we are going to have the graph of this linear equation, we go back to sheet 1, okay, and then click Megastat, click Correlation Regression, and then Scatter Plot. Okay, our horizontal axis is our dependent variable, which is the mathematics performance, and the vertical axis is our uh, wrong. The vertical axis would be the mathematics performance rather, and then the horizontal axis, let's delete this one. The horizontal axis would be the self-esteem. Horizontal axis is our independent variable, and the vertical axis is our dependent variable. Okay, as we can see here, we have plot the linear regression line. Okay, then click OK. So wait for a while, okay, to generate the graph. Okay, so this line is our model that will explain the self-esteem and the mathematics performance relationship. So the model is y equals 2.087x plus 40.655. So that means this line will describe the relationship between the self-esteem and the mathematics performance. So the interpretation is that the mathematics performance will increase by 1 point if the self-esteem will increase by 2.087 points. Okay. And the R squared is 0.871, means 87.1% of the data is being interpreted or accounted by our model. So that's how we are going to use Megastat to present our data.